First stage is to remove the head unit from the box and remove the keeper plate. It has to be positioned on the magnets with the wooden side facing the magnets. Move it off and then put on the sides. Stage is to assemble the handle. Take the centre section out of the flight face and offer it up to the unit, inserting the two bolts clamped into place. They're fastened with the Allen key supply. The circular multi-pole collector can then be connected to the head unit. This supplies power to the motors and clicked into place. And then TruFlux can be wheeled onto the calibration plate to start the calibration. Battery from its flight case and connected to the TruFlux unit. There is a plastic tab here which has to locate on the metal tab here, and the contacts are on the base of the battery like so. So slide that firmly into place, and then you rotate the key in order to lock the battery in position. Step is to put the laptop onto the mounting plate. This can only be done when the head unit is on a metal plate, as the TruFlux unit is then stable on the ground. We have a key here which is used to lock the laptop into position, rotated anti-clockwise, and removes the laptop's now securely in place. The USB cable supplied is then used to connect the laptop to the head unit where the magnetic field strength sensors are. This transfers data to the laptop and supplies power to the electronics. So first of all, we plug into the USB socket on the laptop, here like so, and then we plug in the USB cable to there, screwing it into place. That's a waterproof connector, and then tug the cable out of the way, like so. The laptop battery must be fully charged because it supplies power not only to the laptop itself, but also to the electronics in the head unit as well. The main battery here drives the motors only. The power switch must firstly be switched on. There's a green LED here to show you the power is on. And then this switch is moved to the right, and the laptop runs standard Windows operating system, which will boot up. Once Windows has been booted, you run the TruFlux software from the start screen by double-clicking on the TruFlux icon here. And the software will start and communicate with the product. The software is started. There are 3 buttons on the display to start an inspection, to run a calibration, and to exit the application. There is a communication status light here, which will be red until a USB connection is made to the head unit. If we plug the USB cable in, then the light will turn green once communications has been established. You can then click Calibrate to begin a calibration. Stage is to select the operator who will perform the calibration and the subsequent inspection. You can select from a previously saved operator, or you can type the name of a new operator in, like so. You then choose the scanner which you wish to use with the laptop, because each scanner has to be calibrated, and then you choose the plate that you're going to inspect. We have a drop-down list here showing different thicknesses of calibration plate from 6mm up to 12 millimeters. These calibrations refer to 6mm plates with a 3mm coating. In this case, we have a 6mm calibration plate, so we select the 6mm option from the drop-down list, and when we're happy with the details that we have entered, we click the calibrate button like so. The calibrate button will turn green when the software is ready to start a calibration. Calibration plate is a nominal 6, 8, 10 or 12 millimeter thickness with 20%, 40%, 60% and 80% through wall indicators in the rear of the plate at approximately these positions in the center. On the right hand side of the plate there is an area of nominal plate thickness where the TruFlux unit must be positioned to start a calibration. We're going to do the calibration in this direction from right to left. The unit will look to see the 20% indication first. The power key here is rotated all the way clockwise to ensure that power is supplied from the battery to the motors in the head unit. You will see that there is a lever here on the handlebars which, when you pull, engages the motor to allow you to drive the TruFlux over on the calibration plate, like so. Position the scanner, press down on the handlebars like so. That operates an innovative mechanism in the scan head which allows the magnets to be lifted from the plate with very little effort, and then the scanner can be repositioned to perform the start of the next scan or wheel back as appropriate, and then re-engage with the plate. Press the calibrate button, then using the lever on the handlebar, drive forwards, and then press the calibrate button a second time to see the result of the calibration. On the bottom pane here, you can see a C scan with the 48 elements of the sensor across here, with a 20%, 40%, 60%, and 80% through-wall thickness indications. The corresponding rectified A scan of each indication is presented on the top pane, and you can check the amplitudes of those are correct. If you're not happy with the calibration, you can click cancel to go back and do it again. If you are happy, the next step will be to position the gates over the echoes. I've completed the first 3 already. The 80% gate is the purple one, positioned here. It's important that the gate is aligned with the phase change of the signal between the black and the white regions on the C scan and at the central minima on the A scan. I will now position the 20% cursor by clicking the mouse and dragging it into position like so. With the cursors in place on the indications, we press the accept button to accept the calibration. You must perform a calibration before an inspection. The calibration will be stored for a period of up to 30 days, after which point a calibration must be done again in order to do another inspection. The calibration is now complete. Start an inspection, close the calibration window, which returns you to the main menu where you can select to start an inspection. The inspection software has 3 tabs: Project, Tank and Plate. The Project tab allows for project information to be entered: the survey date when the inspection is being carried out, the operator name, the client, and the location of the tank that is to be inspected. Comments can be entered in the comments field here. These are reproduced on the report at the end of the inspection. A colour map, which is used to display colours in the C-scan corresponding to different through-wall thicknesses, is displayed here. This can be edited as required. The tank tab shows a top-down topographical view of the tank that is being inspected. This dynamically changes as more plates are scanned and incorporated into the inspection data. The colour bars on each plate show the percentage of the surface area of the plate of that depth. The plate tab shows in detail the corrosion map of each scan pass that has been taken to map out the corrosion on the plate that is being inspected. Once in the tank screen, it will appear empty as no scan data has been collected yet. We select the diameter of the tank that we are going to inspect, either by typing a value in or using the up and down buttons as I'm showing you now. When we're happy with the tank diameter, we then enter the plate number that we are going to scan first of all, using the row convention. So row 1 dot plate 1 will be the first plate we inspect, and then we press return. We are then returned to the plate screen as shown. In the plate menu, the most important thing to set is the dimension of the plate. In this case, 1200 millimeters by 600. We then need to select the thickness of the plate. We click on the drop down button here. These are the names of the calibrations that we have saved. The 6mm plate calibration we saved as 6mm, so we select it like that. The scan direction is important. A raster scan means to scan in one direction, to turn around at the other end of the plate and to scan back again. A fixed scan is where you are scanning towards the wall of the tank and you need to perform scans in one direction only. The orientation of the scan, horizontal or vertical, is selected here, and the datum for the plate is defined in the start point selection here, either bottom left, bottom right, top left or top right. Comments can also be inserted into the comments box. These appear in the plate section of the report. End zones is a useful feature of the software. Because the scan head has an active sensor in the center of the mechanical assembly, it is not possible to get that to the edge of a scan plate. Therefore, at the edges of the plate, there is normally an unscanned area. By clicking on end zones, this allows you to scan that area to fill in 100% of the plate coverage. The next step is to press the scan button or press F5. This takes us to a screen where we can see the scan strategy. Track 1 in this direction, followed by track 2, and track 3 to complete the plate. If I go back to the previous screen and then select end zones, as so, and then press F5 to start the scan, you can now see that end zones are now incorporated in the scan strategy as track 4 and track 5. Press the start button or F2 to begin scanning the track. Scanning track turns green. You can pause the track or stop if you need to. Otherwise, scan the track. So you're at the end of the track and the scan is complete. Press the stop button or press F2 and the scan is shown in the appropriate area of the plate view. Press the accept button or F4 to accept that scan. The software now says it's ready to scan track 2. Press start or F2 and then scan the second track. Press stop at the end of the track And track 2 is also displayed on the plate view. Once the final track has been scanned, pressing the Accept button returns you to the plate view, where you can see all of the scanned tracks that made up the plate. To look at the inspection data in more detail, right-click anywhere on the scan, select Full Screen. You may then move the cursor around or pan the scan. A selection of zoom tools are available from this menu, and the colour map corresponding to various through-wall thickness depths are shown on the top of the screen. We can also export the image to file by right-clicking and selecting Save Image, as so. Or return to the normal view by right-clicking and selecting Exit. Once the inspection is complete, you can return to the Project tab to create a report. Firstly, you must enter a name for an operator, like so, a client, and a location, and then click Create Report. TruFlux software is installed on the C drive in the TruFlux folder here. We go into the projects folder and into the name of the project that we have just done, and to see the report that's been generated, we click on the Reports folder and we can view the PDF of the inspection that we just completed with the information and comments that we entered. A tank floor view is shown and the plate view. We can customize reports by including customer logos and names into the headers and footers of the pages of the report. To do this, we just need to have logos provided by the customer, and we can customize the PDFs accordingly.